Hello, today we are going to factor a difference of squares and a sum of difference in cubes. One of the things that would be helpful is if you recognize your perfect squares and perfect cubes. So take a moment, pause the video, and on a separate sheet of paper, a sticky note, or even an index card, jot these squares and cubes down so that you recognize them as you're working. So the first thing we're going to talk about is the difference of squares. Notice that we're talking about a difference of squares, which implies subtraction. So you're going to see one square subtracted from another square. That's going to factor to two binomials. One's a sum, one's a difference. And of course, the order does not matter. So if you have a squared minus b squared, you know you're squaring a and you're squaring b. So it's a plus b, a minus b. If we have x squared minus 4, we're squaring x, we're squaring 4. That's going to factor to x plus 2 and x minus 2. Pause the video, take a moment, and attempt these three. Factor them completely if they're possible, if it is possible. Notice one of them is different than the others. So pause the video and try to factor these three. So x squared minus 36. What are we squaring to get 36? So that's going to factor to x plus 6 and x minus 6. We had 4x squared minus 1. So you're noticing that 4 being a perfect square, and you have the x squared. So this is going to factor to 2x plus 1 times 2x minus 1. And again, realize that the order in which you write them does not matter. Now on the last one, we recognize that we have two squares in x squared and 25, but this is a sum, not a difference. Therefore, anytime something cannot be factored, we use our two words, not factorable. If you were to write no solution or undefined or something of that nature, it would be incorrect, because we are factoring expressions, not solving equations. So write the words not factorable. Now let's get into our cubes. So let's start. All right, let's start with a sum of cubes. So here we have a cubed plus b cubed. So that is going to factor to a binomial times a trinomial. The binomial will always take the sign of our original expression. So because we're dealing with sums, the binomial is going to be plus. Okay. The trinomial will always start with the square of the first term in the binomial you'll always have the opposite sign. So if this is plus, that's going to be minus. And then you multiply the two terms of the binomial, so the opposite product, and then you square the second term in the binomial. So you will often see SOPs, square, opposite product, square. Another way of getting the trinomial after you recognize the two terms of the binomials. For example, if we have x cubed plus 8, I recognize that I'm cubing x and I'm cubing 2 to get 8. So I will write x, 2, 2, 2. So now to get the components of my trinomial, I can circle. So I'm circling pairs. X times x gives me x squared. I know this has to be minus because we have a sum. So now x times 2 is 2x, and 2 times 2 is 4, with this last term of the trinomial always being plus. So what I would like for you to do, pause the video and take a moment to attempt these two problems. You're going to factor them completely. So as we factor x cubed plus 64, we recognize that the binomial is going to be x plus 4. So to get the trinomial, we can square opposite product and square. Or we can go x, 4, 4, 4, and circle. We got x squared minus 4x plus 4 times 4 is 16. So 8x cubed plus 1, recognizing that we cube 2 to get 8 and we're cubing x to get the x cubed. So our binomial is going to be 2x plus 1 because we're cubing 1 to get 1. So again, we can go 2x, 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 and 1, 1, 1. So for my trinomial, again circling pairs, I'll have 4x squared minus 2x times 1, which is 2x, and plus 1 times 1 is 1. So it's going to be important, again, that you recognize your squares and cubes to make this easier. So now, let's take a look at our difference of cubes. So a difference, again, we're talking about subtraction. So we're going to have this subtraction symbol in between. So if it's a cubed minus b cubed, it's a minus b. So now notice we have minus, so that's going to make that sign in the trinomial plus, because they are always opposites. The last term still being plus, being positive, and squaring the b, we have our opposite product. So again, if we got x cubed minus 8, our binomial is going to be x minus 2. we have the square, opposite product, square. Or again, x, 2, 2, 2, x squared plus 2x plus 2 times 2 is 4. So what I would like for you to do is pause the video, take a moment, and attempt these two problems. So if we have x cubed minus 27, recognizing what we're cubing to get 27. So our binomial is going to be x minus 3. Our trinomial is going to be x squared. We got minus, so the opposite is plus. X times 3 is 3x. Last term is always plus. 3 times 3 is 9. So with our 8x cubed minus 1, our binomial, 2x minus 1. So again, we can do 2x, 2x, and 2x, 1, 1, 1. So 4x squared. We have a minus, so that's going to be plus 2x plus 1 times 1 is 1. So remember, as you're factoring, you can always check yourself by multiplying it out. So for example, if I take x minus 3 times x squared plus 3x plus 9. And I multiply that, should get what we originally started. So we'll multiply the x by each term in the trinomial. That'll give me x cubed plus 3x squared plus 9x. Now we'll multiply the negative 3 by each term, get minus 3x squared minus 9x minus 27. So when we combine our like terms, we have x cubed, we have plus 3x squared and minus 3x squared, so they will cancel out. We got plus 9x and minus 9x, they will cancel out. So we're left with minus 27, which was our original expression. So we know we factored it correctly. The beauty of factoring, you can always check your answer. So in summary, you might want to again pause the video and write down the appropriate formulas somewhere near where you wrote the squares and cubes down, so that you have not only the numbers but the formulas as a point of reference.